Alright, so in chapter 12, we're going to be doing things a little bit differently than what we've been doing. You're actually going to be taking notes on paper. So if you need to, press pause, get yourself a piece of lined paper or whatever that you want to take notes on. The directions, the notes are going to come right out of your text, your classroom book, that you can just look at while you're in class. But if you're looking at this, you might not have looked at it in class. So I have the pages here, and I'm going to go through some things. I'm going to kind of show you back and forth and show you what we're doing in class. But again, you're going to probably want to write some stuff down, so you're going to be wanting to press pause a few times throughout this tape. Basically, we're just going to read through things and talk about what's important. You're going to be defining them on paper. A frequency table is a list of the outcomes in a sample space and the number of times each outcome occurs. And so we're going to make a frequency table that looks like this, okay? Where you've got the type and the number and then your total, and that's it. That's a frequency table. It's that simple. How often does something show up? And so you're asked to look at this table, and it's kind of hard, I won't lie, but it talks about equilateral isosceles and scalene type triangles, okay? And then you'll do a quick check. So if you kind of see, I just count the number, record that in tallies, and then transfer those tallies into the sheet. You can kind of see, or into the table, the frequency table, okay? So again, this is a frequency table, okay? Now, you can take a look at this example, press pause if you need to, and I want you to try quick check number one, okay? Quick check number one just says, do the same thing using acute, so less than 90 degrees, equal to 90 degrees for right triangle, or greater than 90 degrees for obtuse, okay? Go through, take a look, tally them up, and then press on pause and you'll see my answer. So, here's my answer. Right here is my table. Now, frequency tables must have labels and numbers. Don't necessarily need tallies. You could do tallies like I did. See how I did tallies in the margin here and then just wrote the number there. Tallies in the margin, wrote it there. Tallies in the margin, wrote it there. They should add up to the number of things that are actually in it. Okay, so 25 triangles, I better have a total of 25. And I did on this frequency table in here in the notes as well. Okay, so again, the answers were 13, 7, 5, and that gives you a total of 25. Yes, the total needs to be there to be a correct frequency table. Okay, then we'll start talking about cumulative probability. Cumulative probability is the probability over a continuous range of events. Okay, you can use a frequency table to kind of find that. It's basically the amount out of. Okay, so for instance, they go on to example 2 here. Okay, you can see the table they give us here. I can make this really simple. If I talk about the cumulative probability of equilateral triangles on this one, it'd be 6 out of 25. It's that easy, okay? Well, they get a little more in depth on some of these because we can include more than one category. Like for instance, it says use the frequency table to the right here. Find the probability that an elderly person living alone will have contact with his or her children more than once a week. Well, one time a week is not that, but less than one time a week is not. But 2 to 6 is more than one, but so is 7. So basically I'm adding up both of these columns together. Okay, you can see that's what they're doing here. They're adding them together, get the total cumulative frequency, and then your total cumulative probability is really, I like to write it as a percent, 68.7%. Okay, so again, I want you to try quick check 2, once a week or more. Take a look at the table, find the probability of once a week or more. So of course, for once a week or more, I would take the same number, 956 over 1391, and add the one time per week as well, 236 out of 1391. With fractions, you just add across. Of course, you get 1192, and when you divide that, you get 0.8569, which is 85.7%. Okay. Make sure you be careful right here with what it's asking because sometimes they're trying to fool you on some of these types of problems. Okay? To example 3, we're going to have you define probability distribution. Probability distribution is a function that gives the probability of each event in a sample space. Okay? You can use a table or graph to show this. You can kind of see what it's doing here. Probability distribution is really making a frequency table and then graphing it. Okay? So this, actually, you don't even need to graph it, okay? Here it asks you to graph it, okay? But this is good enough, okay? the quick check here is silly, so we're going to do this together. What I want you to understand is if I got two number dice, they keep calling them number cubes. They're just dice. Probability if you're rolling the sum of them being a 2, obviously you're never going to roll a 1 because they both are 1 minimum on each to give you 2, is 1 out of 36, which is the same as getting a 12. In the middle, well, that frequency happens more often because there's more chances of it occurring, and you can see how it all worked out. I would want to have you simplify these, so this would be 1/6, this would be 1/9, this would be 1/12, this would be 1/18, and so on. Okay, and the same going the other way actually. Okay, here it says use the table or graph to show the probability distribution for one roll of a number cube. Well, that's just plain out silly. Now look at what it looks like, probability distribution. I did mine the same, right here, sum, frequency, probability. The sum for one dice would be 1, 2, 3, 4, 5, 6. Well, the chances is only 1 out of 6 for every one of these. That's why I write 1, 1, 1. Now, again, if the total was like 1, 2, 4, 2, 6, 5, then I would add those all up to get this bottom number. And the frequency over that would be what I'd write here in the probability, such as it is here. There was 2 out of the total, there was 3 out of the total, 4 out of the total, and so on. Okay, they got the total by adding up this, and you can see that's why there was an arrow there. Okay, all right, next page. So we're going to look at, you know what? I think that's going to be it for regular. Yep, that's going to be it for you guys. We're not even going to look at these. I'm not that worried about it. I'm just going to have you do the homework now, which is page, and again, these notes are on Google Classroom as well. Page 651 to 652, number 1 through 7. I'm going to talk about number 7 with you in class, so if you really get confused by that, don't let that freak you out. We can talk about it. If you look at number 7 here and then on the homework here, I'll pull this out from under it so it's not confusing here. Number 7 in the homework says use a table or graph to show the probability distribution for the number of days in each of the 48 consecutive months. Well, the number of days, 28, 29, 30, 34, 31 in each of 4 consecutive months, if you can just figure out, January, February, March, April, May, blah, 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 go through how many days are in each one, then you'll set up your probability table again to look like the one that I showed you a few minutes ago. It's going to, again, look a lot like this, where your numbers are going to be 28, 29, 30, 31. Your frequency is going to be how many months that occurs, and then the probability would be that many out of 12, right? So that's just kind of get you started on that lesson, on that problem, and again, you have to do 1 through 7. This is kind of hard to see on this. I'm not sure if it even shows up better in Google Classroom, so I'll probably remind people to try number 6 in class as their first problem they start on. And then if you are seeing this on the video, then you might have to come in and do number 6 real quick when you sit down in class. Have a good day.